Okay, so here we are going to look at 2016, question 4, part B. Right, nice little juicy connected particles question with a movable pulley. Okay, so if we look at our diagram here, we have the two fixed weights, 5 kilograms and 7 kilograms, and a movable pulley of 14. Okay, just checking the other two fixed pulleys here, they are small, smooth fixed pulleys. Okay, so we can basically ignore them. Now, we are asked to figure out the tension of the string, and that's fine because that's always a good starting place. And we're given something a little bit weirder, so we'll worry about that later on. So part 1. First thing we want to do is draw a diagram. So we'll take each piece in turn. So here is our friend, the 5 kilo weight. All right, what's the forces? Well, there's a string on it, pulling up with a tension, and it has a weight going downwards of 5g. All right, then we have the 14 kilo pulley. There it is there, with a string coming up each side and a tension of T. So 2T going up overall. It's called the 14 one, and that means, of course, it has a weight going down of 14G. And finally, we have the 7 kilo fixed weight. There it is there, and just like the 5, nice and simple, tension going up and 7G going down. Okay, so we are going to then try and figure out our force equals ma questions. But before we do that, we have to think of the acceleration. This is the one just to be a little bit careful on. Sometimes it's hard to know, are these going up and is this going down, or vice versa. It doesn't really matter. We can take a guess and we can adjust that guess as we go along. All right. So I'm going to say for the moment that the 14 kilo is going to go down and these two are going to go up. So this guy is going to go up with acceleration a. That's not so bad. Every bit this goes up, it releases a chunk of rope here. But so does this guy. Now, what we might find is that this may not work evenly because this rope can slide along this. This one could go up faster than this one's going down. So we're going to say that this one's going up even, is going up with B. Okay, acceleration B. Which means that this guy is then going down with A plus B all over 2. Again, like I said, I actually don't know if I'm right, if these are going up or if they're going down and that's going up. It doesn't really matter. I'll just get negative accelerations. It's to do with how we define which one is positive. Okay, so, but this is the critical one to watch. You get that right, then everything else comes together. So, stage 2, F equals ma. All right, so let's run our F equals ma question, calculations across the rest of these guys. Well, in this case, I think it's going to go up. So T minus 5G equals 5A. It's not so bad. This guy here is a little bit funkier, but we will say 14G minus 2T. Okay, now it's going to equal mass by acceleration, so 14 times A plus B all over 2. All right, and that's going to equal 7A plus 7B. All right. Now on this one here, we think we're going up, so T minus 7G equals 7B. Watch that. So here's our equations. Now there's a couple different ways you can go about this. Basically, we want to solve for T. So in this case, I'm going to figure out, I can drop it into this equation here just to finish that guy, or 14G minus 2T. If I can put T in there, this whole thing comes out quite nicely for tension. So I'm going to figure out what A is in terms of T and G, and B is. So that means A equals T over 5 minus G. So just divide everything by 5. And B equals T over 7 minus G. So these are nice and tidy. So I can sub in these equations into here. So we'll sub in A and B, which means here that we have 14G minus 2T equals 7, T over 5 minus G plus 7 factor T over 7 minus G. All right, do a little bit of housekeeping, then we'll get another line in here. We're looking for the tension, so I'm going to send this guy across here. Minus 2T equals 7 over 5t minus 7g plus t, 7 over 7g, minus 7g. This guy coming over becomes minus 14g. All right, let's bring ourselves up to here. So just squeeze it in on the right hand side here. A little bit of housekeeping on everything here. We have minus 2t equals 7 over 5t plus t, so 12 over 5t minus 28g. Okay, so our t's are going to come across here then. So we have t factor of minus 2 minus 12 over 5 equals minus 28g. Do the maths on that one, and that is going to be minus 10 over 5 minus 12 over 5, so it's minus 22 over 5. And we just make everything plus because it's kind of annoying otherwise. And now we're coming together quite nicely. So t is going to equal 5 by 28 all over 22g. So t equals, and again, just because you're in an exam and it's getting tired and your brain stopped working, we'll run that through the calculator. 5 by 28 equals divided by 22 70 over 11 g, and that's our tension. Okay, now just in case this one actually wasn't super clear, if we were to put that into actual numbers, t equals, of course, 70 over 11 times 9.8, 62.36 newtons. Okay, if you're ever in doubt, that took about 10 seconds to do, stick it in. Now for our second piece, we're going to turn the page over. So just a little reminder, 2016, question 4, part B. And this is part 2. So what are they asking us in part 2? If instead of starting from rest, the movable pulley has an initial upward velocity, time taken until it changes direction. Well, changes direction means its velocity is going to be 0 at that instant in time. So if you think of this one, this is really a v equals u plus at question under it all. We're looking for the moment in which the velocity is 0. The initial velocity is going to be 0.8. We need the acceleration and the time. All right, we're looking for the time, we have the acceleration, because if we go back to this guy here, acceleration of this guy is actually going to be a plus b over 2. So let's put that one in there. 0.8 plus a plus b all over 2 for the time. Okay, so again, coming back here to this one, we're actually pretty close to getting a plus b over 2 because we have it sitting in there in this equation. So what we're going to say is that a plus b over 2 is going to be equal to 14g minus 2t all over 14. So what we've done is we've taken this equation here, this guy here, we divided by 14 on this side, and we have our acceleration of the movable pulley. Okay, well, what we need now is to figure out t. Of course, we find t, so it's a question of just kind of putting some of these bits and pieces in there. So in our case, we'll actually work it out in terms of g's. It'll come out fairly nicely. So that is equal to 14g minus 2 times 70 over 11g. 14. I can see this is going to come out fairly nicely. 140 over 11 g over 14. Divide everything by 14. This gets a little bit prettier. G minus 10 over 11g. And that is going to equal, space here, 1 over 11g. All right, that's our acceleration. That equals, pop this into numbers here now, 9.8 divided by 11.89. All right, so now come back up to this equation here. 0.8, 0 equals 0.8. Now just bear in mind, they were talking about an initial upward velocity. So they're setting up as positive and this is negative. So strictly speaking, my acceleration is minus 0.89 t. All right. So t is going to equal 0.8 over 0.89. T equals okay, we'll call that 0.9 seconds. There you go. Sometimes these ones look a little bit weird and funky, but actually when you lay them out nice and clearly, see where you need to go, it's fine. Okay? Have a nice weekend.